Good morning, my dear kids. I'm Sridhar, your physics teacher. In today's class, in the chapter vectors, we are going to discuss the addition and subtraction of vectors. Today, we'll try to discuss about all the different laws which are there to add vectors: analytical triangle law, parallelogram law, then the polygon law of vector addition, and also the corresponding subtraction. So as usual, like as you know, like in the previous class, what was the main discussion is like the algebra. So what was our main purpose? Like how to add two physical quantities which are having the magnitude and direction. Only physical quantities having only magnitude, there was no problem. But here even directions also there. So what has to be done? What care has to be taken? That's what we are trying to focus here. So here nothing but you can say like some sort of a new mathematics is what we are going to introduce, and that's called like a vector algebra you can call, or vector mathematics. So let me begin the class. So today's class, it will be about the positive and so like positive and negative. So here the symbol, it's like addition and subtraction of the vectors, and corresponding theory is what we are going to discuss here now. What is the laws? Like the first is what like called as a triangle law of vector addition. First one, I'll begin from here. We'll start with the next page. The triangle law. What is the first one is the triangle law of vector addition. I think there's any problem. Yeah. And there's a triangle law. What is the triangle? I think we know like these are the triangle will be there. It will have three sides. So here, if two sides of a triangle represent adjacent sides of a triangle, then the resultant is given by the third side drawn in the reverse order or in opposite sense. So here the vector, so there's a bar, next the vector, it is b bar, then the resultant is given by the third side of triangle drawn in reverse order or in opposite sense. No, what will be that? So now this will become vector a bar, vector b bar, this will be c bar. So whenever if you take the vector, what is the feature? Like we define this as like a called as a tail, I'll increase the nib size. So this arrow, this particular point, this arrow which indicate direction is called as the tail, and this is the head of the vector. No? Then here the vector a bar, it represents one of the side of triangle. What about the vector b bar? It represents another side of the triangle, and these two are called as adjacent sides of triangle. The resultant is given by the third side taken in reverse order or taken in opposite order. Then suppose say this length of this is a, length of this is b, this is c. So what is the thing? So if I move from tail to head, it should be taken as positive plus a. If I move from tail to head, it's taken as b. If I move from head to tail, I'm going in reverse order, no? So therefore it will become minus c. Or here we'll write r bar, the resultant, equal to 0. So therefore a bar plus b bar equal to r bar. So what is R? R will become resultant. The third side taken in opposite sense or opposite order will give the resultant of these two vectors. So what is it? What is this law? What this law? If two vectors represents adjacent sides of a triangle, then the resultant is given by third side taken in reverse order. What do you mean by reverse order? Like from tail to edge. So how to get the resultant? You should draw the vector. The resultant vector should be from the tail of, how it should be directed? Should from the tail of first vector to head of second vector. This is what the law says. This is very important, though this is something very simple. Almost in all our physics, whenever we do come across a concept, we will be using this triangle of vector addition only. Very easy. Easily we can predict the resultant of two vectors. Then is it a vector addition? Properties of vector addition, will go for it. Properties of vector addition means, so like so now what I did, I added from a vector a bar to b bar. No, if I had b bar to a bar, will I get same result or any changes? A few questions we are going to ask ourselves. Okay, I get this. So a bar, b bar. So I'll begin like this. Yeah. Here only we'll take this. There's a vector a bar, and this is the vector b bar. So this is a bar, this is a b bar. So one student, what he'll do, like he will add a bar to b bar. There's the basic thing. So he will add a bar to b bar. Then what conditions will arise is what we have to check it. What will happen to when we add a bar to b bar? We'll get the resultant vector. So here I'm going to shift this vector b bar here like this. Then I'll bring the resultant vector r bar. Now you see this. This is the b bar. So what is r bar? R bar equal to a bar plus b bar. Now, shall we shift a, and what is the condition? The vector a bar, b bar, they must be free vector. Already they're not bound vector, they are the free vectors here. Now, instead of another student, what you'll do, instead of shifting that one, you will shift a bar. So now what is the vector addition here? A bar plus b bar equal to r bar. Now let me shift this one here. So if I shift this, I think I need only no, this was the vector a bar. So what we do is like we are going to shift the vector a bar. I'll show this. It'll be easy for you to learn. Like I'm going to shift it. You can see that. So finally, what I got the same a bar, same resultant. But what we are going to do, we are going to add up. Like I'll move from tail to edge plus b bar. Then tail to edge plus a bar. Then edge to tail minus r bar equal to 0, or b bar plus a bar equal to r bar. So whether you add first a bar to b bar or b bar to a bar, the resultant, the orientation the length of the resultant and its orientation will not change. Suppose if this is the alpha, it will remain same. And you measure the length of the vector in both the cases, it's going to be same. So they show that a bar plus b bar equal b bar plus a bar. So this is called like a commutative law. So what is the commutative law? A bar plus b bar equal to b bar plus. There is no need to bother. So will I add a bar to b bar or b bar to a bar? Do either one, you're going to get the same resultant. Next one, associative law. I need set off. I need a little bit more space. We'll move to the next page. So this will be associative law. So associative law, let's take three vectors. Well, let me take the three vectors. So there's a vector a bar, there's a vector b bar, and let there be another vector c bar, which is very little bit of some length less than compared to other vectors. So this is a bar, this is b bar, this c bar. So what you are going to do, a student, what he does, first you will add a bar and b bar, the resultant you will add to c bar. So first if I had a bar and b bar, so there's a primary diagram, which let me keep it aside for reference. Then what all I do, here I'll be showing it. So there's a thing. So here, what we do is we are going to shift the b bar. I'll shift the b bar. Something happen. There's a b bar. So then the resultant should be the r bar vector. So resultant of a bar plus b bar from tail of a bar to b bar, I should produce. So this, I'll call this as say r1 bar. It is some vector r1 bar. So then after this, what has to be done? The c bar should be, I'm going to add this r1 bar to c bar. Or c bar, I'm going to add to this r1 bar. So let me pick up only those. I'll try my level best to put in a very systematic diagrams. Yeah, I'm not bothered about this. This b bar I'll remove, so that will be easier. Now c bar is what I'm going to shift it. So it will be shifted here. Yeah, see things clearly. This is c bar. Now the resultant. The resultant from where it will go? From the tail of r1 bar to some other colors. I have other color, yellow. Yeah. So look at this. So this is what the r bar. So let's write all the things. Here a bar plus b bar minus r1 bar equal to 0. So therefore r1 bar equal to a bar plus b bar. Looking at this triangle, plus r1 bar plus c bar equal to minus r bar. Plus r1 bar plus c bar minus r bar equal to 0. We have added first a bar and b bar. No, let me keep this. So this is a bar plus b bar plus c bar equal to r bar. So what we added, first added a bar, b bar, the resultant that will be added to c bar. So instead of that, shall we first add b bar, c bar, then the resultant I'll add to a bar. Will I get the same r bar, the orientation? We will try. We will try. First, what I should do, I should add C bar to B bar here. So this diagram as it is. No, we have to add C bar to so this is the C bar, no? Put C bar. Then I'll get some result. Is it equal to, don't write R1 bar. It is some other value. So I'll call this as P bar. Let me take it some other color. So this is what you can call it as some P bar. So what is P bar equal to? P bar equal to B bar plus B bar plus C bar minus P bar equal to 0. So therefore P bar equal to B bar plus C bar. Now this A bar I'm going to add for it. A bar I'm going to add it. The P bar is what I'll shift from this in this diagram. Then the resultant. So what we are trying to do, we are going to check again the same R bar vector has to be will be there. Yellow color. Okay, this yellow color, it is here. Now you check it. Finally, this will be R bar. Means like will I get same answer, same length? Yes, it will be same length. If you go and check this angle, final angle made by the R bar with A bar. Here also you check this angle, both will be same and both are having same length. So what we did here, no? A bar plus P bar minus R bar equals 0. So therefore what is R bar is equal to A bar plus P bar. This will put it in this way. Some brackets will introduce. So this will become B bar plus C bar. Now you clearly see things here. Both are equal. How equal? If I measure the length of the resultant vector R bar in this diagram, then if I measure the length of the vector R bar in this diagram, both are same and both will have same orientation. So therefore, these two are equal. So what is the conclusion we can make it? This is called like the associative law of addition. So what is the conclusion we can make it? A bar plus B bar plus C bar in fact equal to A bar, B bar plus C bar. Means if there are three vectors are there, you can add any two vectors. It's not that you have to pick up this vector only. There's nothing, there are no any conditions. I hope you are able to understand what I mean to say. So is it 3? I'll take it 4. Even you take it 4. So which vectors I can pick up? You can pick up any two vectors and start adding them. So these are the laws which are brought to understand things. Then, okay, I think finally, what is R? The length of this vector will give the magnitude of resultant. The length of this vector will give magnitude of resultant and its orientation, what angle it makes mid horizontal. So that will give the orientation. Now, if you look at this, yeah. So let's do one thing. How do I measure this length scale and how do I measure alpha to a protractor? And if you take look at the scale and the protractor, due to the marking, there'll be some error. There'll be some error will come. So therefore, the graphical method what we have, the triangle law of vectorization, it will introduce some error. Okay, theoretical discussion, okay, but practically this will be a little bit, will end up with some error. The final resultant, when you measure it, it will have some error. Why do that error will come? Due to precision of the instruments, because we are going to use scale and protractor. So here we'll write this comment. These are something very, very important. The R and alpha. The length of resultant vector R is measured by scale, rural scale, and angle made by resultant vector R which horizontal is measured by protractor. Then the scale as well as protractor will have some error, and that error depends upon the precision. The scale and protractor will introduce errors. These are measuring instruments, so definitely they will have error. The scale and protractor will introduce error in measurement. And that error depends upon precision of instruments, and error depends upon its precision. Or we'll write it, just precision. So therefore, this triangle law of vector addition will end up with some error, will not be accurate. So shall we put here triangle law of vector addition will not give accurate result due to precision of instruments. This is the thing. So can I use this practically? It's not advisable. So therefore, what to do now? Okay, I have alternative. I will go for a method where that's a formula there. I'll substitute in the formula. What are the known things like usually in the triangle law? So we'll be knowing this vector A bar. There's a vector B bar, and I know the angle between them. So that will be sufficient. I need not to measure this A bar, B bar. Just if you know what is the vector A bar, its length, its magnitude, A and B, and if you know angle between vectors, you can bring the result in. That's what the parallelogram law of vector addition proposes here. So because of these drawbacks, no, we will proceed to the next law called as parallelogram law of vector addition. Okay, what is this? This law, parallelogram. Everyone knows there's a parallelogram. Which are adjacent sides. Suppose if this AB, these two are called as adjacent sides. These two are called as opposite sides. These two are called as adjacent sides. So what that law says, like if two vectors represents adjacent sides of a triangle. Sorry, here parallelogram, sorry, of a parallelogram taken in order. If two vectors represents adjacent sides of a parallelogram taken in order. Or not needed. If two vectors represent adjacent sides of a parallelogram the resultant is given by diagonal of a parallelogram. Okay, let's start. There's a vector A bar. Then next we have there's a vector B bar. Are you seeing any parallelogram? Yes, very much, definitely. So in fact, there is a line not visible. Okay, I'll change it. I'll change it. Okay, this will be visible now. Where is the vector? Where was the vector B bar? The B bar was here, no? Adjacent sides. Okay, this was the vector A bar. There's a B. This B bar is what I shifted. Then the resultant is given by the third side of a, so like the result is given by the diagonal. So where this diagonal, I will draw from the tail of first vector to head of second vector. I think don't say tail of first and the two, it's a no parallelogram. The diagonal represents the resultant of A bar, B bar. Now, what was our question like? What will be given for us? The given things will be, so what are the given things? The given things will be for us, you know vector A bar, and you know this vector B bar. I will make it let's a bit more long. No, you can say this is vector A bar, B bar. This is the angle between the vectors. And this is what we'll say theta equal to 0 degree line. So look at the angle between vectors A bar and B bar. What is theta? Theta, I'm going to call it as angle between vectors. So that theta here shall I show it? And the resultant will make some angle with vector A bar, that is what? Alpha. So what is my question? So we want to find out the resultant. To know the resultant, what you need the length and this angle alpha. How to calculate is what we are going to bring a formula here. So sir, I'll measure by scale the length, and I'll measure this alpha by protractor. Then the scale and protractor will introduce errors. So therefore, it will not be accurate. To overcome that problem, we are bringing this parallelogram. So I should not use any instrument. Just by mere this much of what will be known A bar, theta, and B. This is called like an angle between vectors. With this, you should be able to predict the the resultant this one. So we should get an expression for R and alpha in terms of A, B, and theta. I will take the same triangle. We'll bring the same parallelogram diagram. Let me draw this separately. The same thing, I'm giving you one separate specific diagram so that it'll be easy for you. This is a vector R bar. This was a vector. Okay, I think color got changed. Yeah, I'll retain the same color. It'll be easy for you. Let's get into this one. The same thing I could have drawn. Okay, let me bring it separately. So this is what A, this is what B bar, this R bar, this alpha. This was a theta, no? So what we did, the vector B bar the vector b bar, where it was here, no? This vector only we have shifted. This vector b bar was here. So what we did, this vector we have shifted and we have brought it here. So what was what? So what angle it makes with the horizontal, the vector b bar, the same theta. Okay, this let me call O. Let me take this as E, also like a P, Q, let it be M. Some symbols will take it. P, Q, let it be M. What we have to calculate the capital R, that's all. The R, that is what the length of that vector is needed. For that, we'll take help of this triangle. So in the triangle OMQ, you look at the triangle OMQ, then OQ square is equal to OM square MQ square. OQ square is R square. OM square is OP plus PM whole square. MQ square, okay, we'll keep it. We'll try to see what we can further simplify. This I'll expand. OP square, PM square, 2OP PM plus MQ square. Okay, I have this much here. So here will represent all the things. What is OP is equal to E? What is PQ equal to B? And what is OQ equal to R? Then we'll jump into the triangle. Look at the triangle. Let me bring everything here only. In the triangle, right angle triangle PMQ. I'm asking you to look at here, this triangle PMQ. In the triangle PMQ, sine theta should be equal to MQ by PQ. So therefore, what is MQ? MQ should be equal to PQ into sine theta. Further, what is PQ? PQ should be equal to B. So therefore, B sine theta. These are very important. And then after this, similarly, cos theta. Cos theta will be PM by PQ. So therefore, PM by PQ cos theta. What is PQ? PQ should be equal to B cos theta. Okay, let's bring all the things. OQ square was later on. Let me substitute in the end all. So that'll be easy for you. Let's go there. I just make changes. Do notice here. Okay, OQ square. Let's substitute all the things in this equation. In place of OQ, what we have? R square. I think I can slide up. Yeah. No, OQ, in place of OQ, what we have? R square. In place of OP, A square. PM, B cos theta whole square, 2. So what is OP? A. And further PM is B cos theta. And what is MQ? B sin theta whole square. R square, A square, B cos theta, B sin theta whole square. So 2AB cos theta. No, these two terms, can we group them? Can we group them? So then this will become expression R square equal to A square, B square, cos square theta plus sine square theta. 2ab cos theta. So then this will become r square, a square, b square. What is the bracket term? Should be 1. Then plus 2ab cos theta. R square, a square, b square. Okay, finally we ended up the answer. Huh? So the resultant r is given by a square plus b square 2ab cos theta. I think this is what we needed. And what is theta? Angle between vectors. Do I know a and b? Yes, I know the magnitude. So shall I use scale to measure r? Not needed. Directly substitute a and b. There's no necessity of that. This is accurate. No errors. Sir, are you sure? No error. If A and B, if there are error, nobody can help you. If A and B are not having error and theta is, there's no error in measurement of theta, no error in the measurement of AB, then no problem. Absolutely. The resultant what we get is error free, that one. So this is the resultant of A bar and B bar. Then what about the alpha? We need that alpha also. So for that, I need space. We'll do one thing. We'll push this triangle. Looking at this, what is tan alpha? Again, in the triangle, OMQ, bigger triangle. This triangle, in the right angle triangle, OMQ. This should be equal to tan alpha is equal to MQ by OM. MQ. What is OM further? OP plus PM. Again, so we don't know this PM and OQ. Let's do one thing. As usual, I had written earlier that the same story, I'll bring it. In the triangle PMQ, sine theta, what you can write MQ by PQ, cos theta, what you can write PM by PQ. So we needed MQ and PM. So MQ will be B sine theta, PM will be B cos theta. That I'm going to substitute here. So then the tan alpha is equal to MQ will be B sine theta. OP is equal to A and PM will be B cos theta. So we got the answer. So what is alpha? Angle made by resultant with vector A bar. Angle made by resultant with vector A bar. So like this is what we'll get this one. So finally, I think that was the goal what we tried. No, we proceeded to obtain these things. So that's what we got. So tan alpha. So angle made by what is alpha? Angle made by the resultant with vector A bar. And we know this length also. We know resultant and also angle made by resultant with the vector. So for that, what you should know, the magnitude of vector A bar, B bar, and what is the angle between the vectors. Sir, what is angle between vectors? I think little bit some awareness. Little bit some small idea I'll share it. If there's a vector A bar, there's a vector B bar. Then this is a vector. Also, let me write A bar. There's a B bar. Where the tail of two vectors are at a common point. you can see that the initial point of a vectors are at common point, or you can say tail of both the vectors are at common point. Tail is usually not preferred one. So I'll say that the initial point of two vectors are at a common point. Then you measure the angle. That will become angle between vectors. There's a one thing. We can also do one thing. I can shift now. I can shift when I shift this vector b bar. It will come like this. So even now what is this? Even this is the will become an angle between vectors. So then I'll erase this. Got it now? So this will be called as angle between vectors. Now sometimes you may end up a situation of this kind. You may end up a situation of this kind. In that case, what has to be done? So like suppose say if I have like this. So what is the angle between vectors? There's a vector a bar, b bar. You just produce this. Produce this line. Then what you're going to do, you are going to shift this vector b bar. I'll shift it. You can see now. I shifted here. Then you see that here the tail of the initial position of two vectors are at a common point. Now what you measure this angle, this will become angle between vectors. This is not angle between vectors. This will become angle between vectors. So this theta is what we have to, if it is given like this will become angle between vectors. There theta, I took it, some other angle, I'll write it so that confusion will not be there. So here theta, what you should call angle between vectors. What is the phi you should call? Angle between vectors. Okay, got the idea? So at many places this will come. So somehow we should be very particular about the angle between vectors, because that is what we are going to substitute here. If you go wrong here, then definitely answers will go wrong. That's why. So when you're using this parallelogram law of factorization, you should be aware of the angle between vectors. Now then, can I add simultaneously more than two vectors? The answer is no. Any two vectors only you can add. It's having its own limitations. So more than two vectors will come. So first I'll add vector a bar, b bar. Then the resultant will be added to with c bar. So like this we can carry on. Okay, this is about the parallelogram law of the vector addition. Now, so what is the use of this? We will just discuss the let me keep this formula in mind, then I'll discuss some cases. There's a one thing. Then we derived this formula. Okay, and the vector diagram. The vector diagram will pick up. I'm just going to discuss the cases here. Okay, there's a data will not disturb this one. This, let it be at this corner. We'll discuss all the possible cases, situations here. So first theta equal to 30 degrees we'll see, then A equal to B, theta equal to, like that we'll vary the theta, then we'll see the what are the possible conditions will come. So first we'll start with theta equal to 0 degrees. Then how those two vectors are. There's a vector A bar and there's a vector B bar. So what do you expect the resultant? Resultant, I should add up. So the resultant is given by, and this will be better A bar, this is a B bar, this is R bar, no? So according to the formula, R is equal to, substitute theta equals 0 here. Then the formula will be R bar equal to A square plus B square 2AB cos 0 degrees. Cos 0 is 1. Then this will become R equal to A plus B whole square and under root of A plus B whole square. So this will become finally, resultant is given by A plus B. Just add the length of this. The length of this, the sum of this plus this is what? R bar. What is the angle made by resultant? Theta 0, put theta 0. So how the resultant? Resultant will be along A bar only. Okay, now second case, theta 180 degrees. What do you mean by theta 180 degrees? How the vectors will be oriented? This is A bar. This is A bar. This will be minus B bar. So what is the resultant? The resultant vector will be less than A bar, no? The length of the resultant vector should be less than A bar. So then the formula will go like this. R equal to A square B square 2AB cos of 180 minus theta. Cos of 180 minus theta is minus cos theta. So A square plus B square minus of 2AB theta 180. So, sorry. Cos 180. No, cos 180 will be minus 1. Then this will become root of A minus B whole square. Then the resultant is given by just A minus B. Sine of 180 will be 0. So alpha will be 0. I need not to write anything. In both the cases, alpha 0. Okay, there's a second situation. The third case, we'll analyze the third case. Third situation, let theta equal to 30 degrees and let A equal to B. What about the resultant? So we'll take help of the formula. So here A equal to B, that one. Both are having same magnitude. And the angle between vectors is how much? It is equal to 30 degrees. Then we'll check it. First we'll use this formula. So the formula, what it says, R equal to root of A square, in place of B square, A square 2A cos 30 degrees. So this will become 2A square, 3A square, yeah, sorry, 2A square cos 30 will be root 3 by 2. A will come outside, 2 plus root 3. Here 1, 2, these two will cancel out. So we'll end up this one. This expression for this. What about tan alpha? Tan alpha. So this will be B equal to A, no? Sine 30. A, this will be A cos 30. So A by 2, sine 30 is 1 by 2. I think both A will cancel out. So this will be 1 plus root 3 by 2. So this will become 1 by 2 plus root 3. This is the tan alpha. So then we'll get the alpha. So how the vectors, how they are actually theta equal 30 degree, A equal to B. There's a vector A bar. There's a vector A bar. Then this will be vector B bar. Both are having same length. So then there's a vector A bar. There's a B bar. So the resultant is, yeah, resultant is given by this one. This is the R bar. What is the length of that R? Is A 2 plus root 3. A into under root of 2 plus root 3. Try to see here. Yeah. And what is the angle? The alpha, the alpha is this one. Hope everyone is able to get in. Sir, how you're measuring alpha? Not by protractor. Directly the answer is available. Sir, how you're measuring the length R? Directly from the formula. I'm not using any scale. So no error. I think, okay, preferred. So this was the use of this parallelogram law of vector addition. We'll see theta equal to 90 degrees. I'm more interested in this. One more case. Yeah. Theta equal to 90 degrees. The first situation it is, I think. Yeah. Theta 90. According to the formula, R equal to root of A square plus 2AB cos 90. Cos 90 is 0. We know very much. So this will become finally A square plus B square. Now, very, very important. Many numericals I'll be using this data. But then we'll go for tan alpha. Tan alpha equal to B sine theta, B sine 90 by A plus B cos 90. Sine 90 is 1, cos 90 is 0. So this will become just B by A. How the two vectors are? This is A bar. Then this was the B bar. And the angle between vectors is how much? 90 degrees. Let's calculate the resultant. So how to get the resultant? So resultant will be, I have to shift. I'll remove this. This will. So then we are going to shift this one. Then the resultant vector is given by R bar like this. This is what that alpha, which we are finding out from the formula. Please do notice, if two vectors are perpendicular, then what is the resultant? Root of A square plus B square. Then what is the angle? B by A. This will be very fundamental, which we'll be using in our most of the numericals. So this is the advantage of the parallelogram law of vector addition. And then the question comes like, then what about the subtraction? Because our heading, what the heading says that there's subtraction is also there. So can we subtract? Is there any formulas are there? So let's analyze subtraction of vectors. Okay, this will be let me finish off. I had to go to college. I'm working in college. I had to attend their classes. I had to go and take classes for the college. I'll finish off this subtraction of vectors. We know how to add. Now here at the same time, we are going to learn how to subtract a vector. So there's a vector a bar. The length little bit will increase. There's a vector a bar. This is the vector b bar, no? Yeah, this is some. Okay, there's a vector b bar. Now what we are trying to do, we are going to subtract. So this is a bar, I'll write it. This is b bar. I want a bar minus b bar. So shall we bring the negative of a vector concept? So here minus b bar will be produced back. The same b bar only. It will become now negative vector. What is this? There's a negative of this plus b bar vector. So minus b bar is there. This minus b bar, I'm going to shift it. Then so the resultant a bar minus b bar is needed. No? So the a bar minus b bar vector will come like this. This is what the resultant. So how we write it? Plus a bar. I'll move from tail to 8. Then again tail to 8. Minus b bar. Minus r bar equals 0. Why negative sign? If I move from tail to 8, positive. If I move from tail to 8, should be positive. But sorry, this itself is a minus b bar. Here you see that I'm moving from positive to negative. So this will be negative here. This is the vector itself is a negative here. So then this will become a bar minus b bar equal to r bar. We are subtracting. Can you show, sir, like a vector where we'll add a bar minus b bar is what I shown it here. A bar plus b bar, yes, they'll be there. So let's compare all the things at one place. So there's a vector a bar. There's a vector b bar. For first, these are the things what we know it. Write it here. Plus b bar, we are going to shift it. It will come here. No, already we know we have done earlier. So this is the where is the arrow? Yeah. Okay, this is the resultant of r dash. I'll write it, or p bar. I'll write it. No, p bar equal to a bar plus b bar. What is p bar? Sum of a bar b bar. Then what about r bar? r bar vector. R bar vector will come in this way. This is what minus p bar minus b bar. Then the resultant, the red color is what we use. No, this r bar. So what is r bar? P bar is a vector sum, the sum of two vectors. And what about r bar? R bar is the resultant, is the subtraction of two vectors. Definitely their two will be different. P bar and r bar cannot be of same length or should be in same direction. They are of different thing. This was the triangle law is what we are trying to show. In the triangle law is what we are just showing, that how to subtract a vectors. And p bar and r bar are different. This is what the sum of vector. This is what subtraction of vectors. resultant of addition of vectors, you call it. And what is R bar? Resultant of subtraction of vectors. And R bar and P bar, length, all no comparison. There is a one resultant, and this is completely another resultant. Okay, let's go for some laws like A bar plus B bar is equal to minus B bar plus A bar. We'll see. I have here, this is the same diagram. Let me retain. Okay, here is what you are seeing. A bar minus B bar is this one. B bar minus A bar, we'll see how things will be. So this will, I think you'll get confused, but better let me draw it. Huh? So minus A bar is needed, no? So therefore B bar will come here. Minus A bar vector will be in this direction. This is plus B bar. Let me shift it. Let me shift the B bar or A bar, either one. Let me shift the, I'm going to shift B bar minus A bar needed, no? We'll shift the minus A bar. The resultant vector indicated by some other color. Is it equal to R? No, it is something like I'll say P bar. This I'll call P bar. Let me call this as Q bar. Is it P bar equal to Q bar? No, P bar is not equal to Q bar. P bar is what? A bar minus B bar. What about Q bar? Q bar is B bar minus A bar. So what about P bar and Q bar? They are equal and opposite vectors, but P bar is not equal to Q bar. P equal to Q and P bar not equal to Q bar. So therefore, what we can write, A bar minus B bar is not equal to B bar minus A bar. It's not commutative. It is not a commutative, is what we are showing it here. And then can we add and subtract? There are three vectors are there, A bar plus B bar minus C bar. Yes, we can perform. Okay, there's a vector A bar. There's a vector B bar, and we have the other vector, say C bar. So we'll go for this one, A bar, B bar, C bar. I want like A bar, B bar, minus C bar. The triangle only. Can we do that? Okay, first shift the B bar. Okay, there's our primary question. Okay, let me keep it here. No, first I should shift the B bar, no, keeping C bar as it is. Now shift this B bar vector. Okay, B bar vector is here. Then the resultant of these two, you call that as R1 bar. That has to be produced from like this. This is the R1 bar. So what is R1 bar? R1 bar equal to A bar plus B bar. Now what I want minus C bar. Minus C bar, how it should be opposite to this vector. Hmm. Okay, opposite to vector minus c bar. Now this has to be added to this. I'll remove a bar and all other things. So this is not needed. This is not needed. This is not needed. Okay, this minus c bar, we will shift it. Minus c bar, I'll add up to this. Then the resultant, so the resultant is what r bar needed, no? So the r bar vector will come in this way. We can just keep on add anything we can add or we can subtract. Now look at the equation. It will be r1 bar plus minus c bar minus r bar equals 0. So r bar is equal to r1 bar minus c bar. What is r1 bar? A bar plus b bar. We are performing both. You can add two vectors, the resultant you can subtract, or you can take a bar minus b bar, add up, or a bar minus b bar minus c bar. In any operation you can perform. Is it a bar plus b bar minus c bar? Is it equal to a bar minus of b bar? Definitely answer is no. You start working out, check it. So this, if you take some a bar minus b bar minus c bar, will be different compared to this. Okay, this even the same triangle law, what we were used to for addition, no, this can also be used for the subtraction. Along with this, okay, this about the triangle law is what we applied even for subtraction. After this, so something like, suppose if there are two vectors are there, but I think that this will be very important. Just make contact. Okay, there's a vector r1 bar. There's another vector r2 bar. I want r1 bar minus r2 bar direction. Then r2 bar minus r1 bar. So here, what is the method is like? Just you can bring this vector, what it can be. Okay, similarly, this vector, what it can be. Now I'll carefully look at this one. For r1 bar, I'll add up r2 bar minus r1 bar. I'll get the resultant r2 bar. Plus, so I'll move like this. Plus r1 bar. Plus r2 minus r1. This two will cancel out. I'll end up with it. And this is, there's a first vector, the second vector. The resultant should be from tail of first vector to head of second vector. Okay, r2 bar minus r1 bar will be directed in this way. Similarly, here this should be r1 bar minus r2 bar. So this is the first vector. There's a tail of first vector, head of first vector, tail of second vector, head of second vector. Now look at this. This will become resultant. So the resultant one, and I'll shade it. We'll just show like this. This is the resultant. Here, this is the resultant. I'll draw a thick. To show that this is a resultant. That's all. I am at least a student for the pen. So here in this diagram, so what we can put, Who is the resultant? Sorry, R2. R2 bar is resultant. Not, I should not show it. I'm just putting this. Okay, fine. So there are some many ways will come. Just the diagram representation. So we'll go back to as usual. R1 bar and R2 bar. So this arrow R21 bar minus R1 bar, how it will be? It will be directed from tail of that vector to this one. So if vector R1 bar, R2 bar are oriented like this, R2 bar minus R1 bar, you have to put from head of this R1 bar to head of the R2 bar in this direction. This will make it thick. It will make some sense. Okay, got it now? Yeah. Okay, there's a one small. So what about the parallelogram? Can we use that also for vector subtraction? Yes, very much. The same parallelogram, what all we studied, the formulas is what we are just going to modify for the vector subtraction, parallelogram law of vector subtraction. Parallelogram law of vector subtraction. So parallelogram, if two vectors is a vector here, then the other vector, this is a B bar. So there's a vector A bar, there's a B bar. I want A bar minus B bar using parallelogram. So this was the angle theta what given for us. The negative of vector is what I should do, minus B bar. Where is the blue color line? Yeah, this is the minus B bar vector. What you have to do using parallelogram, how to find out. Then what is theta? Theta is angle between A bar and B bar. Now what is angle between A bar and minus B bar? 180 minus theta. This is what that angle. So this angle will give some specific symbol. Let me call that as phi. And we know A bar minus B bar, how it will be directed. The resultant will be directed somewhere here. R minus I like it. And R plus, how it will be directed? R plus will be directed here. So what was the formula for R minus? So where is the parallelogram? I'm not seeing parallelogram. Yes, you do get a parallelogram. Patience, I'll bring parallelogram. So small diagram I'll do it. Look at now. So this is A bar minus B bar. Where is this vector? So this vector is R minus. It will make some angle. Let me call this is beta. Let me define all the things. They are going to help us a lot. beta. This is alpha. Okay, this parallelogram law of vector subtraction. So let me take the vector a bar and b bar, then minus b bar, a bar minus b bar. We have to find out the magnitude of a bar minus b bar. So there's a minus b bar. Then we know this, the resultant of a bar and minus b bar will be r negative. In this triangle has shown it. Then resultant of a bar plus b bar is what? R plus is what I'm showing. The a bar plus b bar will make an angle alpha with a bar. The a bar minus b bar will make an angle beta with a bar. This beta and this r minus the resultant of a bar minus b bar is unknown thing which you have to find out. So this angle between these two, b bar minus b bar should be 180. So theta plus phi should be 180. Let's come for this one. So what is theta? Angle between a bar and b bar. What about phi? Angle between a bar and minus b bar. Then the resultant of the difference, these two should be, so we'll go for this one. What is the angle between a bar and minus b bar? Phi. In place of theta, you should write this angle between vectors. Then phi, what you can write 180 minus theta. Cos of 180 minus theta will be minus cos theta. So this is the resultant of a bar minus b bar. Then what about this beta? Beta b sine phi by a plus b cos phi. Sine of 180 minus theta. Phi is what? Will be 180 minus theta. 180 minus theta will be, I'll write one step. B sine theta, a minus b cos theta. So with this, what happened? We are able to determine the r minus and also the angle made by the a bar minus b bar with vector a bar. We can use the same parallelogram for even the vector subtraction also. These are the end formulas. Let's go for polygon law. I have vectors here. A bar, B bar, C bar, and D bar. So what I do is like how to get the resultant. So here this vector A bar, B bar, C bar, D bar, let them represent the sides of a polygon. Then the closing side will be represented by the resultant vector taken in reverse order. So now let's do one thing. Plus A bar, plus B bar, plus C bar, plus D bar. Minus R bar equals 0 because I'm moving from head to tail. Minus R bar. So the resultant is given by this one. So this will become closing side of a polygon. These vectors A bar, B bar, C bar, D bar represent sides of polygon. This will become closing side of a polygon. So the resultant is given by closing side of polygon taken in opposite sense. Now any number of vectors can we add? As any number of vectors we can add. Not only this, we can add any number of vectors. Just only some, maybe sometimes while discussing theory, we may come across situation of this one. Okay, so this is about the basic overall picture about the addition and subtraction of vectors theoretical part. So what we do is in tomorrow coming class, we'll take the numericals on these things. Okay, what we had is only theoretical description. You can better say like some sort of information is what we have gathered. Now we'll take the different set of numericals, and in those numericals, how we apply all these concepts or all this theoretical information, how we can use in different situations, and that will become the working of numericals. Let me end up the class. Okay, kids, like in today's class, we had a we have entered into the vector algebra part. The first primary thing is like the vector addition of two vectors. That's what we have started today. So first we started with the triangle law of vector addition. Then from after triangle law, it was only a graphical method where we should use scale and protractor. Then what was the problem with that is like due to there'll be an error in the measurement of resultant and angle made by the resultant. That is due to precision of an equipment. So to overcome that graphical method, because not accurate. So to overcome that, we brought the parallelogram law of vector addition. In the parallelogram law of vector addition, there's no necessity of any instrument. Straight away, we have a formula. If you know magnitude of A bar, B bar, and angle between those two vectors, then you'll get the resultant. I think this was a very powerful formula. But what is the drawback of this? At a time, you can add only two vectors. What happens if there are more than two vectors will come? Then in that case, first I'll add with A bar, B bar. Then the resultant of that I'll add with C bar. Then we went for the polygon law of vector addition. This is very simple. Again, it's a graphical one. We don't have any formula for that. Then the vector subtraction we have introduced is nothing but again the another sense you can select it's addition only. The addition of vectors only. We have just put it in another way. The same formulas, parallelogram law of vector addition, what we have, that only is being modified for vector subtraction. So this is the one core fundamental part of the vectors. Almost at many places we'll be using this concept here. So in tomorrow's class, we will take some set of numericals where we will see that how we will start thinking. Okay, till then, bye kids, take care, see you.